Hello, we are here for one more lesson of this T-Flex CAD training course, and the topic for today will be the bottom-up design. We mentioned in our previous lesson that when we work with assembly files and we are talking about 2D at this moment, we will see this in 3D later in this course. We have two different methods, the bottom-up, which we are going to talk a little about in this lesson, and the top-down that we are going to talk in our next lesson. But this bottom-up approach, the assembly model design starts from creation of separate assembly elements, or what we call fragments. To remember, a fragment, it is a file that we insert inside another file. And we start with this standalone document, and we insert it inside another one with certain rules and with what we can call special mechanisms to position correctly these fragment drawings inside another one. There are several elements, and we will see a little about all of them. So we will start first to create one very simple drawing as usual. So we will create something around here, a rectangle, and graphical line. So simple rectangle. And before we save this file, we need to create the first type of these special elements called a fixing vector. So we have in here fixing vector, which in fact it is a vector that will define the origin and the positive direction of the x-axis, and this will work as a local coordinate system in your drawing. So fixing vector, we will choose from here, for example, to here. There are a couple of options, so we can use this as default. Okay, it's already done. This is also has to do with the several fixing vectors if we have several ones. We can use only one point, only the first point. In this particular case, the position will be done only by that point, and it will not have any rotation after, but I will leave this out because I want to rotate it. We can link this to layers, and we can link this to also to work plan. So I will not make it very difficult now, just seeing the basic concept. So just do the OK. The fixing vector, it is created, and I will save my file, just calling it file1, and save it. Now I will start a new drawing that I will use to be as my assembly drawing. I will create origin just to snap it for insertion. So now I will call my fragment, choose my file, file1, and as you can see, the drawing is rotated and orientated to have this fixing vector as my x-axis positive. So now I will insert it where I want, okay, and I can rotate it as I want. So this is the idea, to have one origin and the fixing vector that allow us to define this change. Before I do it, I can create some additional transformations that I can connect to variables. Okay, and I can do. It's a good and a very interesting possibility to have this done also with the possibility to have the variable. So if I see on the transformation, so I can have these in variables instead of values, so which allows me to make a parametric change or creation of this insertion. So this is one possibility. and to run briefly the parameters that are connected with the fragment insertion. This is quite basic. Choosing the file, give it a scale, the scale with a line width, which is easy to understand also, to create a symmetry about the fixing vector. If we have text, ignore this symmetry. We can recalculate the 3D models after having this fragment insertion done. We can use the status of fragment or not, and these embedded elements or not also. Okay, a couple of options, and a couple of options also regarding the creation of this fragment and the behavior regarding exploded the fragment with or without creation, or just simply don't use it. We will see later in this course, when we talk about 3D fragments, more possibilities. And besides, when we finish all the lessons, because if you check in our YouTube channel, we've just published 2D and 3D examples. We will complement this with a couple of assemblies, where all of these minor details will be shown in more detail, because we will simulate actual drawing or mechanical assembly. So we will go deeply in these parameters. So this fixing vector, it is the first possibility we have to attach the fragments. The second possibility, it is something called the fixing points. And the fixing points, it is something that we use when, to give you an example, when we want to have our fragment to make the adaptation on the moment that you insert it. So the idea is to create fixing points, and instead of creating now the origin, I can say create fixing points. So I can say, okay, do here a fixing point. I can create my drawing after, okay, something like this. Doesn't matter. Let us simply create now some graphical lines. And save this as file 2. And going again to my assembly drawing, choosing fragment, choosing the file 2, and in this particular case we have only 1 point, so it's used as a fixing point which we can change. Okay, but return to edit, sorry. If we go back, and instead of only 1 point we choose more fixing points, so in the moment we insert it, what happens it is, what happens, file 2, what happens it is that the system will ask to define the other points, and the shape, it is changed according to that choice. Another interesting characteristic we can see about this insertion of fragments and, for example, the connection between variables, it is the possibility to have assembly variables defined, and when we insert one fragment inside one assembly drawing, that insertion can be changed according to the values we have defined in the variables. Explaining a little easier with an example. I will create one drawing that I will use as my assembly drawing, so simply creating one origin, And now I will create one variable. I will call it A, and simply I will create it as having the value of 50, and OK. I will save it as assembly, and I will create now another drawing that will be my fragment, and OK, something like that. I will create a circle, and with a variable that I will say will have the value of 30, and it will be an external variable to be used in other drawings. So just say OK, and I will call my variable editor to change something else. And the idea in here it is to say when this drawing is used as a fragment, you should get the value from the variable A. So just say OK, OK. Put a graphical line on top, and I will create a fixing vector to this side and save it simply as frag. So now going to my assembly, I will insert my fragment, choose the file, choose the frag, and you see the B will get the value from my A variable. So just insert it, and if I create a dimension, you see it has the value of 50. So now I will make this a little different, and choosing my fragment, choosing my file, this one, and now instead of saying no, read the value from A, I will say no, I want to say 20. And it will change my value. So this is a parametric possibility when we insert the fragment, because it can be connected to assembly variables. So this is quite interesting and allow us to create this quick adaptation on the moment of insertion. Finally, another thing that I want to show you, I will use one example. It's another type of element that we can use working with the insertion of fragments. And this element is called the connector. And the connector basically allows us to connect one or more variables from a fragment to other variables of another fragment. And the idea again is to have this parametric behavior in our drawing. I will not develop too much the topic how to create all of this, because we have to create a lot of parameters and a lot of connections with entities. I will leave this more deeply when we publish the assembly examples, but I will show you at least what is the behavior and what we look for when using these connectors. I will insert from the library a bolt, an hexagonal bolt, so it can be this one. So right click, insert as fragment. I will put it here. It's not particularly important. And I will go there again and say now I want to put a nut. Can be this one. Insert as fragment. And you see that the nut has a completely different diameter of my bolt. So now when I connect this bolt with my connector, it recognizes the diameter and immediately adapts. So I will say yes, I will position it where I want, it doesn't matter, and say insert. Okay. The idea now, it is when I change, sorry, when I, not this one, when I choose my fragment of the bolt and say variables, I can have this in terms of variable list or not. If I change, for example, my diameter to 30, everything will adapt independent of the position I have in my drawing. So this is the purpose of the connectors. Okay, this is quite interesting, and this brings a parametric behavior to the drawing, which allow us to create a lot of things and very fast. So these were the main concepts I had in my mind to show you in this bottom-up concept of design. Some topics were left out of this to avoid having a very long lesson, and some of these topics that were missing as explanation here will be developed in the following lessons, because other areas and other commands will help to insert all of these specific items of the assembly drawings. Anyway, any help you may need, or anything that may not be clear in this lesson, you know what to reach us. Send us an email or a comment, and we will we will help you in all the things you may need.